Okay guys, so I've set up the grid for the second lot of questions. So this is question 2A and then 2B and 2C will follow. So it's a reaction between calcium and oxygen to make calcium oxide, and you're given 2 moles of calcium, 2 moles of oxygen. So what is going to run out first and be our limiting reagent? So got two possibilities here. That could run out first, the calcium, so I'd have 2 moles of that. All right, so if all of that reacts, how much of this will I need? Well, it's a 2-to-1 ratio. Where did I get that number from? 2 to 1. That's the ratio there, okay? So it's a 2-to-1 ratio. So I've got 2 moles here. This number here must be half that. So I need 1 mole of that. Okay, and if all of the O2 reacts, so how much O2 do I actually have? The purple number, put 2 moles there. So now we're going from here to here. The ratio, reading it this way, will be 1 to 2. So the number here must be twice as big as the number there. Okay, and then I've just got to have a look and see which one of my 2 pathways will happen. So 2 moles of that will need 1 mole of that. Do I have 1 mole of that? Yes, I do. So I'm pretty confident that'll happen. Let's just prove that the second one doesn't happen. 2 moles of this, so that's all of this to react, would need 4 moles of calcium. Do I have 4 moles? No, I don't, so I'm going to cross that out. So 2 minus 2 is 0. 2 minus 1 is 1. So I can clearly see that is in excess, and this is limiting. So the reaction will finish once all the calcium has reacted, because I've still got some oxygen left over. So now I know what my limiting reactant is, which is that. What is the ratio to my product? Well, you can see big numbers, 2 to 2. So if 2 moles of this reacts, 2 moles of this will form. How many moles have I actually got? I've actually got 2 moles, very fortunate that. So if all of that reacts, it's a 2 to 2 ratio, or 1 to 1, 2 moles of this will form. Okay, so again, hopefully you're starting to get a bit more confidence with this. All right, I'm just going to pause the screen, clear the board, and then we'll have a go at question 2B. Okay, folks, so I've set the board up for question 2B this time. So let's have a look what we've got here. We've got 10 moles of calcium and 2 moles of oxygen. All right, they react in a 2-to-1 ratio, so 2 to 1, 2 to 1, all right, which is brilliant. So same sort of thing. If calcium reacts fully, so if all of that reacts, how much of this will I need? Well, it's a 2-to-1 ratio, so 10 moles of this will need 5 moles of this. So this number has to be half the size of that number, okay? And then let's play the other scenario. If all of this was to react, that's where that number came from there, 2 moles of that, 1 to 2 ratio, would need 4 moles of this. So then I have a look, what have I actually got at the start? I've got 10 of that and 2 of that. Can this reaction happen? Have I got 5 moles of oxygen to react? No, I've only got 2. So I'm going to have to cross that out straight away. So it's the bottom one that must occur. Then I do a quick subtraction. So 2 minus 2 is 0. 10 minus 4 is 6. So what have I got left over, and therefore in excess? It's this one here. So the calcium is in excess, which means the other one is my limiting reagent. And that's the one we use to work out how much product we are going to get. So what is my limiting reagent? It's oxygen. All right, now the ratio here, look, is 1 to 2, which means that 1 mole of this will produce 2 moles of this. So what will 2 moles of this produce? Well, because it's a 1 to 2 ratio, 2 moles will produce twice as much product. Okay, so 2 moles of this, 1 to 2 ratio, will give us 4 moles of that. Okay, again, I'm going to pause the video, have a go at question 2C right now, and then I'll go do a little walkthrough when you click play. Okay, folks, so we're going to be looking at the final question on question 2, which is question 2C, and this time it looks more complicated, but it's not. Just because we've got decimals here, it doesn't mean we do anything different. So again, I know these react in a 2-to-1 ratio, so 2 to 1, 1 to 2, and then I'm just going to transfer the correct numbers down. So I know 0.50 there and 0.20 there. And now I can work out, by just going along these arrows, how much of the other chemical I actually need. Well, 0.5 in a 2-to-1 ratio means that must be 0.25. And 0.2 in a 1-to-2 ratio, because we're going this way, would mean 0.4. So let's have a look. Here's what I've got at the start. Here are the two possibilities. Which one can actually happen? Which one do I actually have enough of the reagents for the reaction to occur? And hopefully you can see I'm going to cross out this one here, because clearly I need 0.25 of this. Do I have 0.25? No, I don't. So I'm going to cross that out. So again, calcium 0.5, 0.4 reacts, 0.10 left over, and the oxygen 0.2, 0 moles remaining. So what is my limiting reagent this time? It's this one here. And then this is in excess. So it's the limiting reagent, which is this chemical here. And just like the last problem, is I'm going to be using to work out how much product I'm going to get. So the ratio of that to that, using the big numbers, 1 to 2. So so let's just use the big numbers to start. 1 mole of that gives me 2 moles of this. So 0.2 moles of this will give me 0.4 moles of that. Because it's a 1 to 2 ratio, that number must be twice as big as that number. Okay, we'll have a look at one of the other questions in a moment, folks. But again, just keep working through these, and I'll try and produce as many of these walkthroughs as possible.